7 ineffective coding habits, but I couldn't make a 1-hour talk fit into 30 minutes. So in the end, I made a decision, which, to be honest, I hope more product people will make, and just be brutal and cut your features rather than ship half the feature for every single one of them. So that's why we ended up with 3 ineffective coding habits that many F# programmers don't have. Before we start, can I just get a quick show of hands? How many of you actually know F#, used it, or read about it? Okay, a couple of hands, but that's okay, because Jason showed you F# earlier. So back to talking about habits. By the definition, habits are things that once we have it, it's really hard to give up. And whilst a good habit helps us make good decisions with a minimal amount of conscious effort, bad habits, on the other hand, make us repeat the same mistakes over and over, often without us even realizing. So this is a talk by Kevlin Henney, who's one of the best speakers around. If you see him on conference, definitely go talk to his talk, see his talk. He identified 7 ineffective coding habits that many programmers have at a conference, I think it was BuildStuff 2014. And I was one of the audience that day. And after the talk, I was really inspired. And when I went back, I reflected upon my own career, what I wanted to call the code I've written in the past, and when I actually show those ineffective coding habits. And at that point, I was spending, I guess, an even split of my time in F# and C#. But when I tried to recall all the places where I showed these bad habits, to my surprise, almost every single case I can remember happened when I was writing C#. And that's not this on C# by any means. I do like C# very much. But it did got me asking whether or not the language that I use or the programming paradigm that I use has an impact on the sort of habits that I end up forming. The great Daisho once said that programming languages have a very devious influence in how they shape our thinking habits. And one might assume that those thinking habits might eventually translate into our coding habits, things that we do day to day. With that, let's start with the first ineffective coding habit, which I'm sure when I say noisy code, we all have some intuitive understanding of what that means, and I'm pretty sure everyone would appreciate that. It's a bit of a negative trait to have. And it's quite easy to see why this piece of code is really noisy, because of the sheer amount of comment attached to what it is, just hello world, or how the code on the left has got a lot more implementation noise compared to the code on the right, which does exactly the same thing, but with much fewer lines of code. And that brings me back to something that Jeff Atwood once wrote more than a decade ago now, that the best code is having no code at all, because every line of code has a cost from the time and effort it takes to write the code the first time around, to having more code means there's more chances for bugs to happen. There's more surface area for bugs to hide. And having more code also means it takes someone longer to read, and more importantly, to understand your code sufficiently to be able to find bugs and fix them. And from psychology, we also know that the average person can hold about 7 items in their working memory, plus or minus 2. It's a very famous number in psychology, so believe me, if you Google it. And the working memory is what we need for all cognitive functions. That means we need to use our working memory to read someone's code, understand it. If not, we have to keep going back and forth. That's why abstractions are so powerful, because it allows us to cheat that limit that we have by grouping space into groups, therefore abstractions. But having more codes means you need more engineers to maintain them. And that also means that you have more people to talk to get stuff done. So from an organizational point of view, you now have more overhead to coordinate and manage more engineers. And going back to what Jeff wrote, I just want to quote one paragraph where he talks about how you should do whatever possible to increase the productivity of individual programmers in terms of the expressive power of the code they write. So having less code to do the same thing, or perhaps even more, is good, because you have to have less programmers to hire, and you have less organizational communication overhead as well. So back to the question I posed earlier, whether or not the language you use has impact on your habits. Objective comparison between programming languages are usually really hard to come by for good reasons. But in F#, fortunately, we had a guy, Simon Cousins. We have a guy called Simon Cousins. He's still with us. He gave us a very good, useful case study based on a real-world application where they implemented it's an energy trading application. They implemented a whole set of energy contracts in both C# and F# to the identical set of requirements. And this was a non-trivial application that took, I think, about 350,000 lines of C# code. And when you compare the two implementations side by side, the numbers speak for themselves. The F# implementation is less than 10% of the code compared to the C# implementation. And when you break down those numbers, something interesting happens as well. Straight away, you notice that because we don't have braces and nodes in the C# and F#, straight away you stream out most of the syntactic noise that you have to produce when you're writing code just to satisfy the language, just to make the language happy. And because when you're writing in C and F# or just in functional programming, you're often operating at a higher level of abstraction that are further away from the plumbing that's involved with imperative style. Remember, when you're writing code in the OO language, a mainstream language such as C# or Java, you're not only programming in OO, but you're also programming in the imperative paradigm as well. And whilst the OO and FP are orthogonal, and in fact, if we talk to many F# programmers, they will tell you that the happy path to adopting F# in .NET is to find the intersection between OO and FP. Object on the large, functional on the small is something that you hear a lot of F# guys talk about, where you still use objects to abstract your code, but inside the object, everything is written in the functional style rather than imperative style. So having fewer lines of useful code, you can implement the same things with fewer lines of code, also has other secondary benefit, because less lines of useful code means fewer lines of blanks to make that code readable. Having fewer lines of code also means fewer lines of comments to explain what those codes are doing, provided that the code you're writing are not significantly more complicated. And if you're not writing in the sort of academic style that Jason showed earlier, in my experience, F# code are very readable and very easy to understand. So all in all, you end up with a much higher signal-to-noise ratio when you're writing in F# compared to C#. But that's not even the full story. Because the C# implementation took 5 years and had at most 8 developers and didn't even end up finishing implementing all the contracts. And it was about 3.5 years into the project that Simon decided, how hard can this be? And then he put a small team together, implemented everything in F# from the ground up. And that project finished in less than a year and had at most 3 developers, with Simon being the only one who's ever had previous experience with F#, which you might argue does help the project, because having someone who knows the language well when it comes to taking on this new project in the new language is very helpful for them. But nonetheless, this is a very interesting case study. It's not a definitive proof of what's better by any stretch of imagination, because it's ultimately still just one case study, and there's other circumstances that we are probably not considering here. Still, it does make you think. All the magnitudes, fewer lines of code, fewer developers, got more done in less time. Maybe there is some correlation there. I'm not sure. I'll leave that to you to decide. With that, let's move on to the next ineffective coding habit, which I like to call visual dishonesty. When Daniel Higginbottom talks about visual design on his blog, which is great, by the way, you go to visualmess.com, he talks about how a clean design is one that supports visual thinking so that people can meet the information needs with a minimum of conscious effort. I think the same principles, same ideas apply to code as well, in terms of how you lay out your code so that the visual relationship between the different elements and structure are obvious and correct. For instance, when you put things over each other with indentation, you are signifying hierarchy. You're teaching your readers how to understand the structure of your code. But then Daniel went on to talk about how you convey information by the way you arrange your design's element in relation to each other. This information is understood immediately, if not consciously, by the people viewing your design, and that's great if the visual relationships are obvious and accurate. But if they're not, the audience are going to be confused. They have to examine your work very carefully, going back and forth between different parts to make sure they actually understand what is going on. Now, you consider how we read English. We read it from left to right, top to bottom. And that's how we normally read code as well, except when it comes to nested method calls, where all of a sudden the flow has been completely reversed. Now we're reading from right to left and bottom up. So all of a sudden we've got this visual disparity in how we visually process and understand the structure of code, which is why, like Jason showed earlier, the pipes idiom in F# is so great, because it allows you to write these otherwise nested function and method calls as a pipeline that flows from left to right and then top to bottom. So this code is all it's doing is it's calling a function called circle with argument radius that's been passed into the function call. And as Jason showed you earlier, all that's doing is finishing that invocation, and the result is passed on to the next line as the second argument to a field function that has been partially applied, and so on. So whereas you would have written this as a nested function call, if you didn't have pipes, you can see clearly, step by step, the transformation starting from radius to some circle that's been drawn in RGB color that I can't decode. And then you have the problem of where do we put our braces and how it affects the readability as well. So Kevlin showed this very interesting technique that you can use, that you take some code, you squint really hard, and for some reason you see everything as X's. But whilst you do that, something interesting happened. Something that we probably didn't notice the first time around, because now I don't know where the method body starts. I know there's some argument list there somewhere, but even though my code is aligned, the structure of my code is not obvious unless I visually eyeball the position, the placement of the braces. Now, if you put your braces on a new line instead, now you squint, well, turns out when you do that, the structure of your code is much more obvious at a glance compared to when you put braces at the end of the line. So it turns out that the way the placement of your braces is not just a personal preference. It has a massive role in how you convey the structure of the application. And there's a right way to do it, which in hindsight, once someone has shown something to us, I think it's quite obvious which way is the right way. But how did so many of us get it wrong for so long? And when I think about this problem, I think it boils down to the fact that in a C-style language, we have two competing rules for how we structure code. One rule for the compiler, which just care about your braces, but then the human need white space to make sense, to understand the structure. When you have indentation in places, that's how you understand the structure of your code. And then you have all these rules out there about how long a method should be. Method shouldn't be more than 60 lines of code. So, you're a really good developer. You want to follow these best practices in the industry. And my God, my function is 62 lines of code. What am I going to do? I know. I'm going to put those braces at the end of a line. So now we're going from 62 to 59. Score. So, unfortunately, when you do that, you're sacrificing readability in the name of readability. So what if, since we know the humans need white space to understand code structure of code, let's just use white space for both the compiler and for humans. Straight away, you can remove a lot of the ambiguity that you have when you have to visually to wrangle with these two different rules. And maybe finally we can stop arguing about where to put your braces at the end or on a new line. Which actually reminds me of something from the Zen of Python that says there should be one and preferably only one obvious way to do things, which incidentally is one of the things that I really like about Lisp, even though I still struggle with the parentheses, but at least the syntactic structure is very obvious, it's very simple, it's also always consistent. So this is how I write the same method in F#, which as you can see, when I squint, the structure of my code is still very clear, even without braces. And also it's much shorter, so that's good, because having less code to do the same thing, or better, is what we're aiming for. And with that, let's look at the last ineffective coding habit, which Kevlin has lovingly named Lego naming. Now, we all know that naming is hard. In fact, I'm sure many of you have read this quote before, that there are only two hard things in computer science, caching validation and naming things. And of course, someone's going to come along later and add and off by one exception. Smart ass, right? Unfortunately, names are also utterly important because they are the one and only tool that we have to explain what a variable does. In every single place it shows up in our code without having to put comments to explain what it is doing. And the common practice that Kevlin noticed, well, actually everyone noticed, is how we like to put different words together, put them together to try to create more meaning. A practice that Kevlin calls Lego naming, using common words such as strategy, process, create, service, disable, exception, validate, blah 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 blah. In fact, it's such a easy automatable process. Why do it yourself? Just go to methodname.com. This is a real website. And you can just infinitely generate suitable names that you can use in your project. So that's not great. But unfortunately, what we're doing is not naming. We are labeling things. And more often than not, when you add more words together, it doesn't create more meaning. And in fact, it probably does the opposite. It dilutes the meaning of the thing that you're trying to name. Which is why we end up with gems such as controller factory. And last year, I went to GitHub and searched for factory. I found a surprising number of hits. And you see on the left, the Java is right there at the top, right next to Ruby. And then I found some amazing gems. Like this one here is a class called the factory. They inherit from a type called the typed game component of generic type factory or generic type factory. And also template factory, interface of type factory and factory of type factory. Seriously, how many times do you have to repeat factory before you realize something's not quite right here, guys? And unfortunately, Lego naming is also not just limited to us programmers either.
This is all based upon an idea of backward causality. If A does B and A is successful, then if you do B, you too will be successful. So being a scientist, I thought, can we automate this process of copying? So I attended a lot of conferences, listening to people talk about strategy, trying to identify various means, or what I like to call business level abstractions of a healthy strategy, or BLAs for short. So here are the common BLAs: digital business, big data, disruptive, innovative, collaborative, competitive advantage, ecosystem, blah, 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 blah. I created a strategy template for this. Our strategy is blah. We will lead a blah effort of the market through our use of blah and blah to build a blah, and so forth. Then I took common BLAs and the blah template and auto-generated 64 strategies. So let's go through them. Number one. Our strategy is customer focus. We will lead a disruptive effort of the market for our use of innovative social media and big data to build a collaborative cloud-based ecosystem, etc., etc. Strategy 2. Our strategy is innovative digital business. We will lead a growth effort of the market for our use of customer focus, competitive advantage, and disruptive social media to build a collaborative revolution, and so on. Number 3, I'm not really, but what? So I sent these out to a load of friends, put them online, and I got about 150 responses of 3 common types. The first one was, this is more or less the exact wording from our business plan. The second was, I've seen 2 of these used already. And the third one was, are you behind?
So that's Simon Wilder doing his keynote at the OSCON a couple of years ago. So why do we keep doing this? Because naming is hard. We have to name every class, every method, every variable, and Lego naming is just such an easy way out. In function programming and in F#, one common practice is to use anonymous functions or lambdas, and by nature of them being anonymous means you don't have to name them. So straight away, you remove a lot of things that you have to name otherwise. And the meaning of these lambdas, they are created from the higher order function that use them. Functions such as map or filter. If you use C#, you have used them already with link. In F#, they're all over the place. This is a 3-line map-reduced task in F#. And also, you might find that a lot of lambdas, they have, because they're very small in scope, you can also get away with shorter names such as X and Y and Z, which often infuriates other programmers looking out from inside, that functional programmers are just so bad with names. The main counter-argument to this, Mark Seaman actually wrote a very good blog post to explain why some of these short names are good, and the best counter-argument came from none other than Uncle Bob in his Clean Code book, where he's talking about how the length of a name should be related to the length of the scope, and you can use very short variable names for very tiny scopes, but for bigger scopes, you should use longer names. So variable names like ing are just fine if the scope is 5 lines long. And the same principles apply when you're talking about lambdas. There are typically a few lines of code. Another thing you see people use a lot in F# is use tuples instead of creating intermediate types. Because with tuples in F# you can pattern match against them, which means often instead of creating a new type with two properties, you can just use tuples and pattern match against them instead. So again, having fewer things to name because you're creating fewer abstractions. This example where we're doing term frequency calculation, where I've got a bunch of blurs, maybe an array, a string, I can use group by. ID is just an identity function, a shortcut in F#. So this is going to give me a sequence of tuples with two elements, and I can, in the next line, when I'm doing a pattern match against it, I can give them actually good names in here. I can use a word and group, GR, just a sequence of strings representing every occurrence of the string that is the word. And then again, I'm going to map them, and then on the next line, again, I can use pattern matching to give them meaningful names without having to create types with those nice properties. Because in C#, you're going to end up calling this as tuple item 1, item 2. Maybe there's is it like underscore first, or is it just item 1, item 2? Item 1, item 2. Yeah. So compared to when you do in C#, this is much nicer, right? We can all agree with that. Another thing that Legonemy can also be a symptom of when you couldn't find the right level of abstraction for the things you're working on. So because now the right level of abstraction, your brain just can't deal with it. You can't come up with one name because it's not quite left or right. And that's partly because in OO, it's hard to model something that is smaller than an object. Often the right level of abstraction is smaller than an object. So what you see people do often is to put a wrapper around it. So you wrap it around an interface or a class, so instead of the thing you're looking for, you end up with a thing that provides the thing that you're looking for, so you end up with two things to name. And since neither of them are at the right level of abstraction, so naming either of them is difficult. So let's do Lego naming instead. But sometimes, when we work hard at this problem, we can come up with much better names than condition checker and check condition. This is a lot better. But for me, this is still a lot more wrapping than what it is that I'm actually looking for, which in essence is a condition. And a condition is something that you can evaluate with no argument and get back a Boolean. So in F#, I can just slap this type alias, and this is much more concise and precise as well. And any function that matches this type signature can be used as a condition without having to implement some arbitrary defined interface I've defined. In fact, as Jason alluded earlier, a lot of OO patterns we find, they are patterns to work around restraints that you have in the language. And when you go to some other language in other communities, you might find that those are just idioms people use. They don't have names for them. And Scott Latchin, a good friend of mine, did a very good talk at the NDC a couple of years ago, where he talks about how you can apply all these, replace all these OO patterns with just functions. In the functional language. Another common practice I'm sure everyone has seen many times is how we like to add the exception suffix when we try to name a type to represent some exception. And often less is more. Class not found is actually a lot. It's very self-explanatory of what it is. We don't need to tell it that it's exception because what else can class not found mean? But that is not always the case. If you remove the exception, you end up with arithmetic array stored, case, cast. So you can't just always just remove the exception and come up with better names. But again, if we think about where we see these exceptions, we can come up with much better substitutes. So the only time we're going to get the arithmetic exception is when we have an integer being divided by 0. So integer division by 0 is a much more descriptive and a precise name for the exception you're trying to tell people about. And security violation, that's something that anyone who's not a programmer can understand. Where you say security exception, well, you kind of have to learn that pattern when you're learning programming. Another common practice in F# is to use the lightweight exception syntax to create lightweight exception types. And the convention there is to not add the exception suffix because, well, you need to tell everyone that what this type is. The only thing this type can represent is an exception. So that's 3 out of the 7 ineffective coding habits that Kevlin identified. You should be find the talk he did at BuildStuff 2014 on the InfoQ. Strongly recommend you go and watch that. And through practice, we all pick up habits, good and bad. And the great American football coach, Mr. Lombardi, once said that practice doesn't make perfect, only perfect practice makes perfect. And that perfection is not attainable. But if you chase perfection, you might just catch excellence. And the default that we have in our language give affordance towards a certain set of behavior and habits. For example, immunity by default affords the habit of being conscious about where and when changes can happen. And programming languages and paradigms, even more so, they have a huge impact in how we think and how we problem solve. And that impact is most profound with the first language we ever learned. Because as human beings, we're all susceptible to the endowment effect, which is where we overvalue what we have, including our experiences and our knowledge. And since every language and every paradigm forces you to think in a particular way, so the knowledge of that paradigm is both a gift as well as a shackle. And from personal experience, learning lots of different paradigms, as many as I can find time to, it does take a lot of effort to unlearn the way that we've been taught to see programming, and to I guess, a lesser extent, to see what is possible. We only see a very small subset of the available solutions to solve any problem that we're faced with, because the constraints placed upon us by the paradigms that we're using, or by the language that we're using. And only by exposing ourselves to more languages and different ways of thinking, more programming paradigms, do you stand a chance of breaking free of those shackles. The journey is very hard, but definitely worth it. And having learned a few different paradigms and languages, I would say that once you've done it the first time, get yourself used to the idea that I can be wrong. The things I've been taught can be wrong. It does get a lot easier going forward. The first time you learn function programming, coming from an old background, it's like, oh my God, what's happening? What's wrong with the world? But gradually, as you come to accept the fact that, I think it was, I forgot who it was who said it, but yeah, that's right. Cow. Damn, I forgot his name. But he's the father of the active model. He actually said once that, and this is one of the most famous guys in computer science. He said that we don't know much, and much what we know is wrong. So for someone like him to admit that, it should be fine for the rest of us to feel the same as well. And so before we go, I just want to leave you with a few more phrases from the Zen of Python, which I really enjoy. That explicit is better than implicit, and simple is better than complex, and complex is better than complicated. Special cases aren't special enough to break the rules, although practicality beats purity every single time. And that if implementation is hard to explain, that is probably a bad idea to begin with. My name is Yan. I work for a company called the SpaceApe Games, so I'm near Tottenham Court Road. Whilst I still have the mic, I'm never going to give it back. We're actually running an event on October the 12th in partnership with Amazon Web Services, where we're going to be talking about data science, machine learning, as well as Dr. Steve Turner is going to come from Amazon and talk about serverless with Lambda, and also I'm going to talk about some of the things I've been working on, building a real-time multiplayer game with Scala and Akka. So come along and see what we are doing. So with that, I think I'm right on time. guess now we open the room for questions.
Are there any questions?
It's okay to not have questions either. That's right. It's almost 9 o'clock.
I have a question for both you and Jason.
Come on, Jason.
We touched on during the break there. Just like you guys are both giving talks on functional programming, how much of your daily life at work revolves around functional programming, and how much they still make you do C#?
Shall I answer that? Yeah, so Jan touched on it a bit there actually as well, about sort of learning paradigms for the sake of how it informs your working every day. So I have spent time building things in F#. I now work for a company where we don't use F#. We use C# almost exclusively. But that doesn't mean that everything that I learned while doing F# and in talking to the guys that I work with, that hasn't informed the way that we write code. So we talked there about OO in the big and functional in the small. So those ideas about having pure functions, having things that are testable, because given a set of inputs you get a set of outputs, all that kind of stuff is infinitely applicable still to an object-oriented language. So I'd say we write we write C# code, but to look at, you'd probably find it very functional. Yeah, I think that's probably all I can say.
I'm out of .NET altogether. I spend most of my time writing stuff in the Scala, and also write a bit of Node.js when I'm writing AWS Lambda functions, which is very different from writing your traditional Node.js applications. But yeah, Scala is what I'm used to working with most of the time. I also done a bit of Erlang in the past as well, but very small bits. So if there's no more questions, I guess everyone should just go home to your loved ones.
Okay, thank you very much. Okay, so that's basically it for the evening. Can I just ask everyone though, after every event, what I do is send out just a really, really quick survey monkey, okay? It literally has like 5 questions on it, and all you need to do is like tick a box. What that will be is to ask you how you found both the talks and to give any feedback that you can. Obviously, positive feedback is great, but we want constructive criticism as well. That's what we call it, constructive criticism. Yeah. But please do give some feedback on the talk, on the event overall, anything extra we can do to make things better. Please spread the word about the events. Please kick your friends if they signed up for a ticket and didn't turn up, which is about 50 people. So we give them a vote because there's enough pizza to feed about another 50 people. As I said earlier, we are hosting the event next month is at Equal Experts. The conference is on the 4th of November. If you're interested at all in that, please just hang around for 5 minutes afterwards. I saw everyone taking a picture, by the way, when Jan said about this other talk. If you paid attention to the emails that I send out, the link to that talk is on the emails as well. Okay, so it will be in your inbox somewhere. But yeah, thank you very much, everyone. Thanks, and have a safe journey home. Thank you. Thank you very much. So yeah, I will send out an email with the details on, and I'll put a link on to talk and I'm going to try and somehow upload